Okay, we are going to uh, continue chapter number 5, network layer and the control plane. Okay, so in the last class we had discussed chapter number 5, link state routing protocol and distance vector routing protocol. So these are discussed in detail through examples. Now, in this class, we are going to continue chapter number 5, and more specifically, we will discuss autonomous system, intra-autonomous system routing, and routing among inter autonomous system routing routing among the ISPs, and more specifically, we would like to discuss BGP protocol. Okay, so we are going now to discuss autonomous system and intra autonomous system routing. Let me explain to you that as we had discussed in chapter number 5 in first chapter, that internet, it is basically network of networks. The internet structure, it is basically network of networks. Okay, so we had already discussed it, but I would like just to remind you, okay, that what does it mean. We know that each end system, it is connected to internet via access ISP, and that ISP, it can be a residential company or university ISP. Okay, so the access ISP, it is interconnected. So the access ISP, they are also interconnected with each other, so that a host from one access ISP can access another host in another access ISP. So this resulting of network is this resulted network of network is very complex. Okay, and we had discussed it. So let's take a stepwise approach again. Suppose these are the access networks, access ISPs. So through these access ISP, the users are the host are connected. Okay, so one approach that could be that these ISPs, they can be reconnected with each other. This is one approach, but this approach we have discussed that it is not feasible. Okay, because it will have the scale, it is not scalable, because it will, in this case, we will need O n square number of connection. So in access ISP in Pakistan, it has to connect to the access ISP in US, which is impossible. Okay, directly connected. So another option that it could be that we could have a global ISP. Okay, and that global ISP, it basically connects these access ISPs or access networks, and this global ISP, it should be in control of first person, one person. It is also impossible. Why? Because there is no one person or there is no one organization that can provide internet connectivity worldwide. Okay, so the another option is that we have different ISPs. We have different ISPs. Like for example, in I could like to give you an example in analogy. Like for example, in the world, we don't have single country. Okay, we have multiple countries, and these countries, they are interconnected. They form the regions, and then the regions are interconnected with each other. This forms the global world. In the similar way that the access networks, they are interconnected with each other through one ISP, regional ISP. Similarly, these access network, they are connected to another ISPs, and so on, so on. And then these ISPs, these regional ISPs, they can be interconnected with each other. Okay, so they are interconnected. So we have different approaches, like we can have IXP, we can have peering links, or we can have content provider network. So we have already discussed it. So my purpose was that I would like to show you that basically internet, it is basically the network of network. Okay, so actually the users, they are connected to the internet through access ISP. Then these access ISP, they are interconnected with each other through regional ISPs, and these regional ISPs, they are now interconnected through tier 1 ISP or through an internet exchange point, and so on and so on. Okay, so we can see that this is one network, this is another 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 network. Okay, so this access ISP, for example, this is the ComStat access ISP, so it is in the control of ComStat network. This is a, for example, PTCL network in Pakistan, and they are connected the ISPs in Pakistan. So this regional ISP, the PTCL network, it is controlled by the PTCL in Pakistan. Okay, so in this way we can say that the internet, it is basically a network of networks. This is one network, another network, another network, another network, another network, and they are interconnected with each other. Okay, like different countries, they are connected with each others. Okay, so we can say that the internet is basically network of networks. Okay, now it basically leads to a hierarchical structure. Okay, so far that we had discussed the link state routing protocol or distance vector routing protocol. So we were assuming that that all routers are identical. One router can access another router. Network, this structure is called flat network. It is flat network, but in practice it is not true. Like I had explained to you, that it basically is not true. Why? Because as we have discussed that we don't have like this one structure that we have discussed, like this one structure. We don't have like this one structure. This is called flat structure. Okay, so we don't have that in one XP is directly connected with the rest of access network. One access network or one access ISP is directly connected with all access network directly. So it is impossible. Okay, so in current practice we have the network in the form of like this one. We have like this one. This is the structure. Okay, in this structure you can see that this regional ISP, basically these access ISP, they are connected through this regional ISP, and these access ISP, they are connected through this regional ISP. Then these regional ISP are interconnected, so it provides the connectivity for this access ISP to connect with this access ISP. Okay, so basically we can say that this is a hierarchical approach. This is the low level hierarchy, this is the top level. Okay, and these regional ISP, they are interconnected through tier 1 ISP. Okay, so we can see that we have a hierarchical approach. Okay, so we can't store all destination in the routing table, and if we store this information, then the routing table will overflow, so it will not be impossible. So what is the option? That the internet is basically network of networks. Okay, so one network, for example this network, it is called autonomous system. This network, it is autonomous system. This network, it is called autonomous system. So one network, it is called a network that is within the single administrative control. For example, this is the regional ISP of PTCL, that it provides the connectivity to the access ISP in Pakistan. Okay, so this is in the control of PTCL. So this is called autonomous system. Okay, so normally we have in the internet we have autonomous systems, and these, what is autonomous system? A particular network, it is called autonomous system. A network that is within the control of one organization, one administrative control, that is called autonomous system. So basically we have different autonomous system in the internet is consist of networks. Networks means autonomous systems, and these autonomous systems, they are interconnected with each other. Okay, so basically the internet is network of networks. So each network administration may want to control routing in its own network. Okay, so basically we can say that the internet approach, we use a word that is called autonomous system. So what is autonomous system? Basically we aggregate routers into regions known as autonomous system or domains. Okay, so if we have a region, for example, you can say that this is one autonomous system, this is another autonomous system, this is another autonomous system, this is another, and this is another, and so on. Okay, but there is another challenge or another very important distinct characteristic, and that characteristic is what? For example, we have three autonomous system like this one. This is one autonomous system number 3. This is autonomous system number 1. This is autonomous system 2. This autonomous system 2, it contains the routers or the host or whatsoever. This network structure is under the controller of autonomous system number 2. This autonomous system number 1, it controls this region, the host, the router, the switches, the server, all the things. This total network is under control of autonomous system number 1 and this, and similarly for autonomous system number 3. Now we have two types of routing. For example, 3C wants to send data to 3B. So there is a possibility that one system, a source node, is sending data to destination, and both source and destination, they are within single autonomous system. So this is called intra-autonomous system routing. Okay, so this autonomous system, it can use link state routing protocol within its network. This autonomous system, it can use distance vector routing protocol in its domain. This can use distance vector also. Suppose, okay, so we can see that if we have different networks, different autonomous system, then each autonomous system is controlled of a single organization. So that organization can use any routing protocol that it wants. For example, autonomous system 3, it is using link state routing protocol. This autonomous system 1, it is using the distance vector. This is using distance vector. Okay. Now, but when the challenge arises, when autonomous system 1, autonomous system number 2, it wants to send data to autonomous system number 3. So this data, autonomous system 2, it cannot send directly to autonomous system number 3. So it has to pass through autonomous system number 1. So when the data is moving from one autonomous system to another autonomous system, so we need the routing protocol. And this routing protocol, it can be called inter-autonomous system routing. So basically in autonomous system, we have two types of routing protocol. One is called intra-autonomous system routing, that is used for communication between routers or among routers within autonomous system. And one is called inter-autonomous system routing, that is used to compute the routing or to compute the route from a source machine in one autonomous system to another autonomous system. This is called inter-autonomous system routing. Okay. So when we introduce the autonomous systems, when we divide the internet in the autonomous systems, so we have two types of routing. One is called intra-autonomous system routing, It is basically routing among hosts or routers in the same autonomous system, that is within the same network. So the all routers in autonomous system must run the same intra-domain routing protocol, yeah, intra-autonomous system routing protocol. For example, other autonomous system can use lect3 protocol or it can use distance vector routing protocol. Router in different autonomous system, it can run different intra-domain routing or intra-autonomous system routing protocol. As I have explained to you that this autonomous system 3, suppose it is using lect3 routing protocol. The autonomous system number 1, it is using distance vector. Autonomous system number 2 is also using distance vector. Okay, so when different autonomous system they are connected with each other, so you can see that this router 3B in autonomous system 3, it is connected to the all routers of the same domain. For example, 3B is connected to 3C and 3A, and 3C and 3B, 3C and 3A, they both lies within the autonomous system number 3. So they are in the same domain. Okay, but this 3A, it is the router that is connected with the routers in autonomous system 3 as well as with autonomous system number 1. So a router that interconnects two autonomous system, that router is called gateway. That router is called gateway. So 3A is gateway, 1C is gateway, because it is connecting one autonomous system number 1 to autonomous system number 3. 1B is a gateway because it connects autonomous system number 1 and autonomous system number 2. 2A is gateway. Why? Because it connects autonomous system number 2 to autonomous system 1. So we can say that if a router connects two autonomous system, then that is called gateway router. It is a specialized router, it is called gateway. And that autonomous system which is not connecting with the more than one autonomous system, that is called normal router. So when we introduce autonomous system routing, when we introduce the autonomous system, that is the internet, when the internet is divided into autonomous system, then we will have intra-autonomous system routing and inter-autonomous routing. And second, that we may have gateway router means these are the routers that are at the edge of its own autonomous system, that is it has links to routers and other autonomous system. So gateway router is a router which is connected to more than one autonomous system, that connects two or more than two autonomous system, that is called gateway router. Okay, so I think this gateway router this topic is clear. It is normally at the edge because it connects one autonomous system with another autonomous system. So when we need intra-autonomous system routing, this is the routing that is used for the host or router within same autonomous system. When we want to move the data from one autonomous system to another autonomous system, then we need inter-autonomous system routing. So inter-autonomous system routing, it is the routing that is used among autonomous systems or among the domains. So basically this inter-autonomous system routing, it is basically performed by the gateway routers or the gateways. So inter-autonomous, because the gateway routers are the gateway, they connects the two or more than two autonomous systems. So therefore the inter-autonomous system routing, it will be running or it will be implemented on the gateways. So gateway perform inter-domain routing. So as well as the inter-domain, because the gateway is part of you can see that this gateway router, it is part of this autonomous system, so it will use inter-autonomous system routing, and it is also connecting with this autonomous system, so it is also using the inter-autonomous system routing. So on the gateway we use inter-autonomous system routing and intra-autonomous system routing, but on the non-gateway nodes only intra-autonomous system routing protocol is running. Okay, so I think this slide is clear now. Okay. Now moving, uh, 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 let's move ahead. So you can see that we have different autonomous systems. Okay, they are connected with each others. So forwarding table configured by both intra and intra autonomous system routing algorithm. I would like to discuss this slide. Before discussing this point, I would like to discuss how the routing is performed between two or more than two autonomous system. Then I think it will be much clearer. Okay. Now let's discuss another important characteristic. I think it will be clear to you. Now suppose that we assume that the gateway it maintains only inter autonomous system reachability. You can see that this is the gateway 1B. It is connected with the autonomous system 2, so it will have the information that is connected with autonomous system 2, and this gateway also have the information that this autonomous system is connected with the autonomous system number 3. Okay. Similarly, that this gateway it has information that it is connected to the autonomous system number 3 and as well as to autonomous system number 2. Okay. Let's suppose that the gateway it maintains the inter autonomous system reachability. That only the gateway knows that how many autonomous systems are reachable from here. Okay, you can see that this gateway it knows that it is connected to autonomous system number 1 and it is further connected to autonomous system number 2. Okay, so if this information is that is the inter autonomous system information, it is only maintained in the gateway. So suppose the router 3B in autonomous system number 3, this it wants to send the datagram outside of outside. For example, this 3B it wants to send a packet. It has received a packet from the host and it wants to forward that packet to 2B, for example, here. So we know that the inter-autonomous, now it comes to know that the packet is going to autonomous system number 2, but it doesn't know that where is autonomous system number 2, because this 3B it only knows about intra-autonomous system routing. In the inter-autonomous system routing, information is present in the gateway in the 3A. Okay, so in this case 3B only knows 3C and 3A, but it doesn't know about autonomous system number 2. So what should it do? So in this case it knows that the 3A is the gateway. We have already discussed the 3A is gateway. So if a node doesn't know about the destination, then the node forward the packet to default gateway. So in this case the gateway is 3A, so the 3B will forward the packet to 3A. When the 3A receives, so it is a gateway, so it has the information that autonomous system 2 is reachable from autonomous system number 1. That the autonomous system number, first the packet should go to autonomous system number 1 and then to autonomous system number 2. So now the gateway can forward the message to autonomous system number 2 through autonomous system number 1. Okay, so this is simple. That now we again I would like to emphasize that suppose we assume that only the gateway routers it maintain the inter autonomous system reachability. So in this case it works fine. However, suppose this 1D it want to send the data to 2C, to autonomous system number 2. Now 1D only knows about 1A, 1C, 1B. it doesn't know about autonomous system number 3 and autonomous system number 2, because this information is only maintained on the gateway. Now 1D wants to send data to autonomous system number 2, so 1D doesn't know that where is autonomous system number 2. So in this case it should forward to gateway, but here the gateway are two, 1B and 1C. So whether the 1D should forward the data to 1C or to 1B or to both. So if the data is forwarded to 1C, then it is far away, but it is forwarded to 1B, then it is closer. Okay, so therefore we also assume that when the gateway they receives the enter autonomous system routing information, the gateway enhances this information, the autonomous system information, this autonomous reachability, this enter autonomous system reachability information to the all the nodes in the autonomous system by using intra-autonomous system routing, because this 1B is already communicating with these routers in for intra-autonomous system routing. So in this intra-autonomous system routing, for example, it is using lect3 routing protocol, it will also distribute the information of inter-autonomous system reachability. So you can see that 1D can receive the information that autonomous system, when 1B announce autonomous system 2 and autonomous system 3 and its intra-autonomous system routing protocol to 1D, 1C and 1A, then and similarly 1C also announce the autonomous system reachability, inter-autonomous system reachability information to its autonomous system routers within by using inter-autonomous system routing. Then 1D can come to know that autonomous system number 2 can be reachable from 1B and is from 1C, but 1B is closer. 1B is closer because so it will transmit the data to 1B. Okay, so therefore I would like to emphasize that the forwarding table that is configured at each router, it is configured by two routing protocol. One is by inter-autonomous system routing protocol that is used within this autonomous system, and by inter-autonomous system routing protocol that is used by the gateway only. So the gateway router, it only use the inter-autonomous system routing as well as intra-autonomous system routing, but the non-gateway nodes, they only use the intra-autonomous system routing. The gateway nodes, they run both inter-autonomous system routing and intra-autonomous system routing. That is, they know about the routing between our two autonomous systems. Okay, and it also runs the intra-autonomous system routing protocol that is used for the reachability among the routers within autonomous system. Okay, but the gateway nodes, it also announce the inter-autonomous system routing information and the using inter-autonomous system routing to its all the routers in domain, so that we assume, so that when 1D wants to send data to an autonomous system and there are two gateway, then it can know that which one gateway is closer, which one gateway is closer to an autonomous system, so that can be so the packet can be forwarded to that router. Okay, so I think it is much clear. So forwarding table, it is configured by forwarding table in a router, it is configured by both inter-autonomous system and inter-autonomous system routing algorithm. Inter-autonomous system routing algorithm, it determines the entries for destination within autonomous system, but inter-autonomous system and inter-autonomous system determine the entries for external destination, that is the destination outside autonomous system. Okay, now suppose that inter-autonomous system, what is the inter-autonomous system task? Okay, suppose router 1A in the autonomous system 1 receives a datagram destined for autonomous system number 2C. For example, 1A, it wants to send data to 2C. So the router should forward packet to the gateway. which one, this one gateway or this one. Okay, so we assume that when autonomous system 1 must learn which destination are reachable through autonomous system 2 and which are reachable through autonomous system 3. That is, we discussed that when autonomous system learns, when the gateway, with the gateway router, they learn the inter-autonomous system routing information. That information is propagated to the all the routers in the network. So that 1D comes to know that this autonomous system 2 is reachable from 1B, it is closest, and this is the far away. Okay. So you can see that learn which destination. So, and this information is propagated to the rest of the routers. So this is the job of inter-autonomous system routing. Now, intra-autonomous system routing, it is also known as Interior Gateway Protocol or IGP. The most commonly intra-autonomous system routing protocol are RIP and OSPF. They are currently used. RIP is a distance vector routing protocol and OSPF is a link state routing protocol. We have discussed distance vector and link state in detail. We have discussed. And IGRP, it is a Cisco proprietary intra-autonomous system routing protocol. Okay, so as we know that autonomous system, when we introduce autonomous system, so we have two types of routing protocol. One is called intra-autonomous system routing. That is the routing algorithm that is used by the router to reach from one router to another router with an autonomous system. So for this purpose, in the intra-autonomous routing protocol can be OSPF, that is used in link state routing protocol, or RIP, which is the distance vector routing based protocol. Okay, or it can be the interior gateway protocol. So we have already discussed the RIP, the distance vector and OSPF in detail, so I will not go into its detail, but we can just have an overview. Okay, so OSPF, it is open shortest path first algorithm. It is open, publicly available, its RFC is available, its complete implementation detail is available. So it uses link state routing algorithm. So you should know that what does link state routing protocol means. Okay, so we have already discussed it. The router floods OSPF link state advertisement to all other routers in the entire network. Okay, in the entire autonomous system, and this information they are carried out in the IP directly in the over IP. Okay. Another is ISIS routing protocol. Also, it is also identical to OSPF. Okay. So this we have already discussed the link state routing protocol. So OSPF is following the link state routing protocol options operation. Okay. Moreover, the OSPF also have some advanced features, and these features include security, multiple paths, etc. Okay. Now we are going to discuss the inter-autonomous system routing protocol, and for this purpose we have the BGP. This BGP, it is the inter-autonomous system routing protocol. As we know that up to now we have discussed that when autonomous system is introduced, okay, so we have two types of routing protocol. One is called intra-autonomous system routing algorithm. So this can be link state or distance vector. So its RFC is OSPF, that is currently used for or RIP. Okay, and now in the next type of routing protocol, another is autonomous system routing. So we are going to discuss this inter-autonomous system routing algorithm in detail in the next video. Okay, so we will discuss this protocol in detail in the next video. Okay.